Okay, so we're looking at practice problems again for Chapter 8, Rotational Equilibrium and Rotational Dynamics. So we've looked at the first problem. Let's skip to the second problem. The problem states that we have a uniform plank that is a length of 2 meters and it has a mass of 30 kilograms. It's supported by the 3 ropes T1, T2, and T3 as shown in the diagram. You can also see that in the free body diagram. Find the tension in each rope when a 700 Newton person is a half a meter from the left end. So we can see all that in the pictorial, and we can also see that in the free body diagram. So we're going to take a look at this just like we have in the previous problem, and kind of like we've done in the past. We're going to look at summing all the forces or the torques in static equilibrium. Okay, so first let's take a look at summing all the torques. Let's see if that works for us. So if we consider the torques about an axis perpendicular to the page and through the left end of the plank, okay, down here, sum the torques, set them equal to 0 because nothing's moving, it's in equilibrium, and then go down the length of the plank and start inserting those forces times the lever arm. So the first one we have, minus 700 newtons times a half a meter. That's the guy standing on the plank. We've got 294 newtons at 1 meter, which would indicate the center of gravity of the plank. And then we have our component relationship of the tension in rope 1 times its angle, the sine of 40 degrees, at the 2 meter point. So we've gone along the length of the plank at each point where we have a force and created a torque value, or force times lever arm. So now what we can do is take that apart and move our terms around, since we have it set equal to 0, and see if we can come up with a value then for the tension. The only tension we have is tension 1. So as we move things around, if we moved T1 sine 40 and the 2 meter value, then we end up with the tension by itself. So 700 newtons times half a meter plus 294 times a meter, and that's all divided by 2 meters times the sine of 40 degrees. Make those calculations, and we can see that tension 1 then on this side is 501 newtons. Now we can switch to the summation of the forces, set them equal to 0 because they're in equilibrium. So let's use the sum of the forces in the x direction. So do the same thing. Let's gather all of our forces. We have minus T3, which has no component associated with it because it's lying right on the x-axis, and add to that T1 times the cosine of 40 degrees. Set that equal to 0 and solve then for the unknown, in this case T3. Because what we're going to do is we're going to do a substitution then, since we've solved for T1 in the previous step, and see if we can come up with the tension in the x direction for T3. And as we enter those numbers, 501 newtons, cosine of 40 degrees, you can see we have 384 newtons. So that's the component force in the x direction. So lastly, let's look at the sum of the forces in the y direction. Doing the same thing. Sum the forces in the y direction. We have the only force T2 up on the left end. We're going to subtract 994 from the weight of the plank, and then T1 sine of 40 degrees. As we enter all those values, again substitute for T1, we end up with 672 newtons. So each of the tensions, all x, all y, and then a resultant value gives us 501, 384, and 672 newtons.